Hello and welcome. This is going to be our lecture video for December 3rd. We're doing a step-by-step binder sheet today. Feel free to do this just on a separate piece of paper and then clip it into your step-by-step binder. Or if you really want to, you can print this off of my extra stuff calendar and fill it out there. All right, so solve each compound inequality and graph its solution. Step 1 to doing this is to determine if you are given an and or an or type compound inequality. Either it will say one of those words and you should maybe circle it so that you remember which type you're dealing with, or if it's a single line like we see in problem number 1, that's automatically an and type. So let's write that. Single line inequalities, single line inequalities are and types. All right, step 2. All right, so for or types, we want to solve each half separately, then graph, and keep both rays. All right, a ray is a line that goes forever in one direction. And every graph we've done of an inequality has been a ray so far. So they start at a point, but then the arrow means that they go whichever direction they're going, all the way to either positive infinity or negative infinity. All right, so for or types, solve each half separately, then graph and keep both rays. All right. And let's add this into these typically don't overlap. All right, step 3. In step 3, we'll cover what to do with the and type inequalities. For and type, solve each piece graph but only keep the overlap. This makes a line segment. All right, and then let's deal with how we solve those single line inequalities. All right, so for a single line inequality, whatever you do to the middle, you do to both sides. All right. So let's actually solve a couple of these. Starting with problem number 1 here. I'm going to copy down some space. We've got 5 is greater than or equal to negative 3 plus v, which is greater than negative 2. This is a single line inequality. I want to isolate v in the middle, so I'm going to add 3 here, but also add 3 to the 5 and add 3 to the negative 2. And I get 8 is less than or equal to v is less than 1. Or actually, that's greater than or equal to v is greater than 1. All right. In order to graph this, I want these to all be less than symbols, so I'm going to take this whole thing and flip it all the way around. Bring the 1 over here, flip that inequality. 1 is less than v is less than or equal to 8. Hopefully you can see that this is just this compound inequality flipped around. All right, this is an AND type. So I'm going to go to graph it. I put an open dot at 1, closed dot at 8. When they're written out as single lines, as long as this number is smaller than this number, then it's always going to give you the line segment in between those two boundaries. Then we can double check with a number like 5, plug it in and make sure it makes both inequalities true. All right, problem number 2. This is an OR type. So here I'm going to solve these inequalities separately. 2k is greater than or equal to 10. 9k is less than 36. This one here, divide both sides by 2. We get k is greater than or equal to 5. Over here, divide both sides by 9. We get k is less than 4. These are our algebraic solutions. We still want to box these. Let's keep the word OR in between. Now when I go to graph them, I'm going to just keep both of these graphs. So k is greater than or equal to 5. I'm going to put a closed dot at 5. Arrows going to the right for that one. K is less than 4. I'm going to put an open dot at 4. Arrows going to the left for that one. And that's our graph. It's every number except for this little gap in the middle. All right, there's a couple more on the back side here. Practice these as well. So another OR type. So we'll solve each half separately. All right, we've got constants on both sides. We'll move it away from the variable by subtracting 8. And we get m is less than 8. We box around that. Over here, to get rid of the divide by 4, we're going to multiply both sides by 4. And we're going to get m is greater than or equal to 4. Put a box around that. And then we're going to keep that word OR in the middle. Now let's graph this. M is less than 8. So it's an open dot at 8. Arrows going this way. M is greater than or equal to 4. Let's a closed dot here. Arrows going this way. These do not link up to make a line segment. This was an OR type. So they cross each other, and our real answer is all real numbers. So why did that happen? Let's write it down. If an OR type overlaps, the answer is all real numbers, just like we wrote for this one. All right, next one, we got 14 is less than or equal to 4 plus p is less than 2. 14 is less than or equal to 4 plus p is less than 2. I'm going to subtract 4 from all three sides. I get 10 is less than or equal to p is less than negative 2. And these are less than symbols, but the problem is this number over here is bigger than this number over here. So p has to be greater than 10 and less than 2. If we tried to graph this, we would have array over here up at 10 and then array down here. But there's no overlap. And this was an AND type problem. So this one's actually a no solution. So let's write what happened there. If an AND type doesn't overlap, the answer is no solution, just as I wrote here. So you want your AND types to overlap, and you typically don't want your OR types to overlap, or else you're going to get an all real number situation. Okay, one more. We've got p over 2 is greater than or equal to negative 2, and 9 plus p is less than 17. Solve each of these for p. Multiply both sides by 2 here. I did not multiply by a negative, so I do not need to flip the inequality here. I'll subtract 9. I get p is less than 8. And it still has the word and in between. So greater than or equal to negative 4. So close dot at negative 4. Arrows coming this way. Less than 8, so open dot at 8, arrows coming this way, and you can see these are going to connect up to make a line segment. All right, that's all I've got for this video. So you are done taking notes now. I'll embed a few more for you to try, and have a good rest of your day.